Welcome to Science Meets Adventure, the place where travel, exploration, and real science come together. Have you ever stood on a mountain at sunrise, watched the sky shift from dark purple to gold to fiery red, and wondered what you were actually looking at? Or maybe you've been on a beach, in a desert, or on a long road trip and noticed that the sky can change color in just a few minutes. One moment, it's bright blue. A little later, it glows orange, pink, and deep red. It feels magical, but the truth is, the real explanation is just as amazing. Today, we're diving into the real physics behind one of the most beautiful things on Earth, why the sky is blue and why sunsets are red. And once you understand it, every hike, every ocean view, every campfire evening, and every golden hour photo will mean even more. Let's start with sunlight. Sunlight looks white to our eyes, but it is actually made of many colors mixed together. You can think of it like a hidden rainbow traveling through space. Red, orange, yellow, green, blue, and violet are all packed into what seems like plain white sunlight. When sunlight passes through a prism, those colors spread out and become visible. That tells us white light is really a blend of different wavelengths of light. Now imagine that sunlight arriving at Earth. Before it reaches your eyes, it has to travel through our atmosphere, a huge layer of gases wrapped around the planet. That atmosphere is not empty. It contains tiny molecules, water vapor, dust, and other small particles. As sunlight moves through all of that, something important happens. The light gets scattered. Scattering means light gets bumped and redirected in many different directions. Instead of traveling in one straight line from the sun to the ground, some of the light is sent off sideways, upward, and all around the sky. But here's the key part. Not all colors scatter the same way. Blue light has a shorter wavelength than red light. In Earth's atmosphere, shorter wavelengths get scattered much more strongly by tiny molecules in the air. That means blue light is flung across the sky in all directions far more than red light is. So when you look up during the day, you are seeing blue light coming at you from every part of the atmosphere. The whole sky looks blue because the air is spreading blue light all around above you. That's the big idea. The sky is blue not because space is blue, and not because the atmosphere has a blue color of its own, but because the air scatters blue light especially well. Have you ever wondered why the sky above a snowy mountain can look so deep blue? Part of that is because, at high altitude, the air can be cleaner and thinner, with fewer large particles blocking your view. That can make the scattered blue light appear richer and darker. It's one of those travel moments that feels dramatic even before you know the physics behind it. Now let's talk about sunsets, because this is where the show gets even better. During the middle of the day, the sun is high overhead. Its light takes a shorter path through the atmosphere before reaching you. But near sunrise and sunset, the sun sits low on the horizon. Its light has to travel through much more atmosphere to get to your eyes, and that changes everything. As sunlight crosses that longer path, more and more of the shorter wavelengths, especially blue and violet, get scattered away before the light reaches you directly. What survives the trip more easily? The longer wavelengths, red, orange, and yellow. That is why sunsets and sunrises often glow with warm colors. You are seeing the sunlight that remains after much of the blue light has already been scattered out of the direct beam. So in a way, a red sunset is what happens when the atmosphere filters sunlight. The long journey through the air removes more of the cooler colors and leaves the warmer ones behind. Have you ever watched the sky change color in just a few minutes? That fast shift happens because the angle of the sun is changing quickly, and the path of sunlight through the atmosphere is changing with it. A small movement of the sun near the horizon can create a big visual difference. But here's another great question. What makes one sunset dull and another unforgettable? This is where travel, weather, and local conditions come in. If the air contains extra dust, smoke, salt, or pollution, sunsets can become more dramatic because larger particles affect the way light is scattered. Sometimes this deepens the reds and oranges. In deserts, dry air and dust can create glowing sunsets that feel almost unreal. Near the ocean, moisture and tiny salt particles can influence the softness and spread of color. After storms, when the atmosphere changes quickly and clouds break apart at just the right moment, the sky can explode with color. Clouds matter too. A completely clear sky can produce a nice sunset, but clouds can turn it into something spectacular. High clouds catch low-angle sunlight and light up in pink, orange, and red. Broken cloud layers often create the most dramatic scenes because they reflect and scatter the sunlight in complex ways. Humidity also plays a role. Moist air can soften colors and create hazy effects, while dry, clear air may make the sky look sharper and cleaner. Pollution can sometimes intensify reds, but it can also make the whole sky look washed out and less vibrant. So the most beautiful sky is often a balance. Enough particles to paint the light, but not so much that everything becomes dull. That's why sunsets look different in different places. A golden hour ocean view may glow softly and widely. A high mountain sunset may feel crisp and intense. A forest sunset can seem more filtered and mysterious because you are seeing the light through trees, mist, and layers of shadow. On islands, in deserts, or above the clouds, the colors can feel almost exaggerated because of the local air and the angle of the light. And that is what makes this science so meaningful for travelers and explorers. When you understand why the sky changes color, you don't lose the wonder. You gain more of it. You start noticing details. You pay attention to the clarity of the air, the shape of clouds, the height of the sun, the season, the weather. You realize that every beautiful sky is the result of real physical events happening above you in that exact moment. That sunrise from a mountain peak is not just pretty. It is sunlight traveling through kilometers of atmosphere, being scattered molecule by molecule before it reaches your eyes. That glowing desert sunset is not just a background for your photo. It is physics painting the horizon in real time. So the next time you are camping, hiking, crossing an ocean by boat, driving through a canyon, or standing on a beach waiting for golden hour, look up and ask yourself, what is the atmosphere doing right now? Why is this blue so deep? Why is that orange so bright? Why does today's sunset feel completely different from yesterday's? Here's the quick recap. Sunlight looks white, but it contains many colors. Earth's atmosphere scatters shorter wavelengths like blue more strongly, which is why the daytime sky appears blue. At sunrise and sunset, sunlight travels through more atmosphere, so much of the blue light gets scattered away, leaving reds, oranges, and pinks to dominate the sky. Dust, clouds, humidity, weather, and local conditions all help shape the final colors you see. So on your next adventure, pay attention to the sky. It is not just above your journey, it is part of the journey. If you enjoyed this video, don't forget to like, share, and subscribe to Science Meets Adventure. See you in the next discovery.